Now we're going to go to our first question that was sent, like I said, by one of our learners. Let's go and check out what this question is all about. All right, so this question says to us here, in the diagram below, point M with coordinates M and 3 is the center of the circle clearly. Q, -4, and Q is the midpoint of chord AB with A, -12 and 2, and B at A and 11. The length of the radius of the circle is 10. Right, so we can all see what is going on. This is information that is appearing on the diagram based on that particular love letter. Like we always emphasize on this show, it is very important for you to analyze the love letter versus the drawing to make sure there is nothing that you're missing out on that love letter that doesn't really show on the diagram. Now, if I go further down now to check the first question, we are required to calculate the value of A as well as Q. Now, if you check on the diagram, you will notice that A is simply the x-coordinate of point B. This is where A is currently sitting. So we are looking for that coordinate, and we're also looking for the y-coordinate of point Q. Right. Now, in order for me to find the answers to this, I'm just going to simply go onto the love letter and analyze that statement that was given to us. You look for the key words. You know, words such as distance mean a lot in analytical geometry. Words such as midpoint, gradient, those kinds of things are very important because you did them since grade 10 and all that work becomes very important when you get to grade 12. In grade 11, our analytical geometry was just about geometric shapes and straight lines everywhere else. Now, in this case, when you're in grade 12, we can now start looking at circles. And if you don't know what these concepts are all about on the Tenfold Education app, there's a lot of background information that we're covering up there. And even on a prep show that comes before this one, we do a lot of assisting you to try and get you to see what is the background info, what is the theory behind what is going on. But I'll do my best to try and help you guys to understand how does one work with these kinds of questions. So now I'm going to go to the information that was given to us. If you check there, we're told that there's a point Q that happens to be the midpoint of that straight line AB, which in this case happens to be a chord. So for me to answer this question, I'm going to use the concept of the midpoint in order to find what the coordinate A and the coordinate Q could be. Right, so if you allow me, let me just come here and say, we know for a fact that the x-coordinate of the midpoint is always given by x1 plus x2 divided by 2, right? This is basically what we know. Now, if you check on the drawing, I need to have two of those things in order to figure out what the third one is going to be. Now, in that drawing, you'll notice that Q happens to be the midpoint. So the x-coordinate of the midpoint is going to be that -4 that you see there. So I'm going to write here that this here has to be -4. And then my first x value, since I'm looking at Q being the midpoint of point A and point B, that x value at A is going to be my x1. And then that big letter B there with that coordinate A will be now my x2. So I'm going to write here now that I am simply sitting with -12 plus an unknown coordinate, and then we need to divide that by 2. So then from here, it's just simple simplification, cross multiply by that particular 2. You're going to have -8 there equals to -12 plus A, and then from here, your A is going to come out as 12 minus 8, which is exactly equal to 4. Now, I'm going to do the same thing in order to figure out the y-coordinate. You start by writing the formula for the midpoint. The y of the midpoint is given by y1 added with y2 divided by 2. This is information from grade 10, guys. You should know this. So the y value of the midpoint, you go to the drawing, you try and check. If I look at that chord AB, what is in the middle happens to be Q, and that y-coordinate of the midpoint is that small letter Q that you're looking at there. And then my y1 will be 2, my y2 will be 11. So I'm going to come back here and say small q equals to 2 plus 11 divided by 2. And then finally, we can then claim that q has to be 13 divided by 2. And that will be the answers of small letter a and small letter q, those two variables. Right, moving on, we're now required to calculate the value of m. Right, so we now need to find what this small m is. So let's go on to the diagram and check what m is and how m actually looks in this drawing. So m happens to be the y-coordinate, the x-coordinate of the midpoint m, which happens to be the center of the circle in this case. Now, what we were also told in this question is that the length of the radius of the circle has to be equal to 10. At the present moment, there is no radius appearing in this. So I'm going to construct a radius. Let's call it MB. I could have used any one that I wanted, but I want to use this one, MB, because I like the fact that the coordinates of B are both positive, so I won't struggle with the negative signs and all that. It's going to be easier for me to figure out the solution. So we are looking for that small letter m, which is the x coordinate of the center of the circle, and we know now that at b, that x value is 4 and the y value is 11. So I've got the coordinate of b, which is 4 and 11. I know that distance of AB happens to be 10 units, and this information was given to us in the love letter there. So with those two pieces of information, I think I have enough to try and work out what the x coordinate of that center is going to be. So let's continue and see how this is going to pan out. Right. So what do we know so far? We know that the coordinates of M, the center, is that small m and 3. We know that the coordinates of point B is actually 4 and 11. We are looking for the value of m if the length between m and b happens to be 10 units. So according to the distance formula, mb squared is x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared. Right. And then when I substitute what we know so far, our length of the radius is 10, so we are sitting with 10 squared equals to the second x value. I'm going to take that small m minus 4 with a square, and then my y values will simply be 3 minus 11 all squared. And then I won't even break that square where there's a variable, because I'm going to manipulate the fact that there's a square, and to undo a square we just need to use a square root. I'm avoiding the idea of actually trying to figure out factors by factorization. So what you're looking at here is simply 8, and 8 squared will just lead us to exactly 64. So I'm looking at 64 here. We still have your m minus 4 squared, and then 10 squared is just simply going to give us 100. Right, so if you go further and you try to figure out the difference between 164 by subtracting that 64 on both sides of the equation, you're going to have 36 equals m minus 4 with a square. Now, when you're here, you're spoiled for choice. You can either expand that square and then get it to a trinomial and factorize, but the easiest route around here is just to figure out what is the square root of this. And then when you take a square root here, you need to always remember you're looking for plus minus the square root of what you have there. And then if you see there, then we're going to have m minus 4 is the only thing remaining on the right hand side. So I'm going to have m minus 4 equals to the square root of 36, which is just simply 6. So if you allow me to finish it here. So now I'm going to say my m is simply 4 plus minus 6, which means m is either 4 plus 6, which is 10, or m is 4 minus 6, which is negative 2. And then we can't accept both of them, grade 12. So you can't accept both of them. You need to check according to the drawing which one of these two x coordinates makes sense according to the positioning of the center of this particular circle. So let's go and check whether the positive x value or the negative one is the correct one that we need to take. And if you go back to the drawing, let's go back to the drawing, you will notice that m lies on the negative x-axis. It lies on the negative x-axis, on the negative side of the x-axis. So the x coordinate has to be negative. So 10 is going to fall off. We're just simply going to take negative 2 as the correct answer for that. All right, so let's proceed and see what will happen. So we're going to say, examiner, forget about that one of 10. The accepted m value is just simply going to become negative 2. All right, now the follow-up question here is the first question that starts talking to you about the center, the equation of the center of a circle. So it says to us here, if m, negative 2 and 3 is actually the correct coordinates of that point m, we have to determine the equation of the circle in the form x minus a squared plus y minus b squared equals to r squared. This is the easiest thing anyone can ever ask you guys, because what you're simply looking for is the x coordinate of the center you put there by a, the y coordinate of the center you put there by b, and your radius you just substitute there. So this is simply going to be a simple, straightforward question, because we know the center has got a minus 2 there as its x coordinate, so minus minus, we're going to have plus 2 squared plus y minus a 3 there squared equals to 10 squared. Our radius was given to us as 10, so 10 squared becomes 100, and that will be the solution to that particular question. This is essentially what is new in grade 12, finding the equation of a circle, where that coordinates of the center will form that point A and B there. The coordinate A and B are the coordinates of the center, and the radius is just the radius. It hasn't changed. The radius has always been the radius. Even now, it is still the radius. Right. Now, the last question here says we need to determine the equation of the tangent to the circle at point A. Now, this is a very powerful question. We need to determine the equation of the tangent to the circle. Now, if you allow me to attempt to reconstruct this circle, right, it's going to be something that looks like that. and we know there's a point A that lies somewhere that side, right? And now we're talking to you about a tangent. You guys should know that a tangent is a straight line that is going to touch a circle at one point. So I'm simply going to say there's my tangent there that is going to pass at that point there. So we are looking for the equation of that line, right? But what do we know so far? We know that for you to find the equation of a tangent, we're going to use y equals mx plus c, because a tangent is simply a straight line, right? Now by now, I feel like you guys should know that for you to find the equation of a line, we're going to use y is mx plus c, and you need two things. You need to have a gradient of the line, and you also need to have a point that the line is passing through. When you've got those two things, you'll be able to figure out what the equation is. It becomes a straightforward question without any complications. Now in this case, I'm going to just write what we know so far, right? The coordinates of A, because it does pass through that. But the problem is going to be finding the gradient. And this is where your knowledge of Euclidean geometry features in analytical geometry to help you to understand how do you find the gradient. So let's see what is going on here. We know that point A here has very nice coordinates. So let me go back up and check what were the coordinates of point A according to the question. It was -12 and that particular point, which is 2. So we are looking for the equation of the tangent at that point there, -12 and 2. That's what we know. So I'm going to write that as the coordinates of A, -12 and 2. And then we've got a center there. This center, we know the coordinates now are -2 and 3, right? So we want you to find the equation. You'll notice that if you're looking for the equation, we need to know what the gradient is, and we need a point. What do we have so far? Yes, we do have a point, which is point A. Those coordinates of -12 and 2 are going to be used, but we're struggling now with the gradient. How do you find the gradient of this? Well, no complications there. What I'm simply going to use is the fact that a tangent is perpendicular to a radius. And we know in analytical geometry that when two lines are perpendicular to each other, you can actually find the gradient of the other one by using the fact that m1 times m2 has to give you -1. So the gradient of the tangent multiplied by the gradient of the radius must give us -1, because a radius is always perpendicular to tangent. This is the knowledge that we gathered from Euclidean geometry, right? So what is the gradient of the tangent? The gradient of the tangent is the one that you're looking for. So I'm going to keep this as m of tan multiplied by the gradient of the radius is y2 minus y1. So I'm going to say 3 minus 2 over x2 minus x1, which is -2, minus 12 is simply plus 12. And this must give us an answer of -1, right? So the rest is just simple mathematics. You're going to simplify and find the solution to that. You're looking at the gradient of the tangent multiplied by, that's a 1 over, that's 12 minus 2, which is simply 10, must give you -10. And if you multiply, sorry, but -1, not -10, my minus already ahead. Right, this is 10, it's actually equal to -1. If you multiply both sides by 10, so the gradient of the tangent is just going to come out as -10. Now I've got the gradient of the tangent, and I also know that the tangent passes through point A, which is what we were told in the question. So I'm going to go back up and say, let's complete it here so you can see everything we're doing. I'm going to say y is mx plus c. My y coordinate is the A value. The y coordinate at point A, which is simply 2, equals to the gradient. We just found that the gradient is actually equal to -10. So I'm going to put that as -10 into the x value, which is 2 plus c. That's -20. We are looking at -20 plus c. So 22 is your c value. And then in conclusion, we can then say to the examiner, therefore, the equation of the tangent is just simply going to become y is -10x plus 22. And that brings us to the end of this question. A very powerful question indeed that shows you that anything can happen if you're doing analytical geometry. They in fact like dragging trigonometry and also dragging Euclidean geometry when they're asking you about circles, because they're out of questions. There's not a lot that a person can ask you when they're dealing with analytical geometry. A lot of the things, you did them in grade 11. That's why some of the grade 11's work is featuring also in this question. So keep that in mind. Your geometry, Euclidean geometry, your theorems might be very, very useful. And in addition, you might also need to go borrow your trigonometry to try and figure out what is going on here.